Hey, ready for chapter 6? Almost. I actually want to go back to a concept on chapter 5 that I don't think I explained very well, but it's important. So when we have two variables and we want to see the relationship between them, for example, here on the graph we have hours study. So the further over you are to the right, the more you studied for a final exam. And your actual grade on that test, so the higher is a higher grade. So each dot here in the scatter plot will represent one student. For example, let's just pick a dot right here for example. This person studied about 20 hours for the test and got about an 85, whereas this person down here studied about 5 hours and looks like they got a 68 or 66, something around there. But each person represents a dot. You plot them all in the graph, and then you see how close they are to a straight line that would cut through the middle of them. The closer they are, using some algebraic formula, the higher the absolute value of the R. And this R is called the Pearson correlation coefficient. Pearson, as far as I know, is not connected to this test at all. This was a statistician a while ago. And a positive 1.00 would be the highest correlation, negative 1.00 would be the lowest correlation. Let me just give you some picture here of what some different correlations might look like. So this would be very strong positive on the top left, something that was definitely related. Perhaps your shoe size in inches and your shoe size in centimeters. Now there should be a complete correlation because all it is a conversion. The higher you are on inches, definitely the higher you are on centimeters. Now you might get something here that's 0.4. What would be a weak positive relationship? Maybe something like height and basketball ability, perhaps. So the taller you are, overall, the better chance you probably have at basketball, but you'll still have a lot of tall people who aren't that good at basketball, and you'll have a lot of short people who are good at basketball. If you remember Spud Webb, he was a really good one a few years ago. 0 is no correlation. The two things are not connected at all. Perhaps height and IQ, and I'm not sure if they are related or not, but you wouldn't think that among adults, I guess I should clarify, among adults you wouldn't think that there would be a correlation between those. If there is, it's very weak. And then over here we have strong negative correlations. So it's kind of a weird concept where the lowest and the highest numbers are the ones that are actually the very strong correlations. And you can see the slope of the line doesn't really matter. All of these right here have a perfect correlation, perfect positive and a perfect negative correlation. So it doesn't really matter what the slope of the line is. That's a different issue. That's what we need in regression to predict. We'll look at that later. And then these, even though they have a pattern on the bottom row, those have no correlation. So we're talking about how close we are to the straight line drawn through the middle of the dots. And a couple more things. If we want to know what percent of the variance, and what do I mean by the variance and why? I mean, if I give a test, you're not all going to get the same grades. There's going to be variation. Some people are going to score high, medium, low. Why? Why doesn't everybody just score the same score? Well, that's why we do correlational studies or causation studies. We want to know, why is there that variability? Is it because of socioeconomic status? Is it because of background with the parent's education? Is it because, more likely, you studied or did not study for the test? Is it because of previous teachers that you've had? Well, we can have many different factors, and if we want to know what percent of the variance can be explained, all we have to do is take this correlation coefficient R and square it. So here we have a 0.89. Let's just say that's 0.9. 0.9 squared would be 0.81 or 81%. So we could say that 81% of the grade is connected to the number of hours studied. But we have to be careful not to say that 81% of the grade is caused by the hour studies. This is only variance explained. This is only a relationship between. Another good example is height and weight. Taller you are, the more you tend to weigh. That's a pretty strong correlation, but that doesn't mean necessarily that if you put on lots of pounds, you will start growing taller and taller. Causation doesn't work that way. So correlation is necessary to have causation, but it's not sufficient. You need some more things too in order to have causation. Okay, so now that I've eaten up a third of our allotted time here on this video, let's just go through 4 different types of ways to measure quantitative data. So a test, you're familiar with the basics of it. I want to just briefly talk about 2 different types. One is norm referenced. In other words, you're giving a test to separate out the students. You want to know within some norming group, within the students in your class, you want to know who's the best and who's the worst at the material. This is often called grading on a curve. It would be that curve that we're talking about is the normal curve. On the other hand, you could have criterion reference. Criterion referenced is, let's say, for a kindergarten class, you want to be able to tie the shoe. Doesn't matter if everyone in the class can tie the shoe, they would pass the test if the criteria is tie the shoe. Versus a norm reference, you may have which students tie their shoes quickest or which students take the longest. You have, you're comparing the students against each other, not against some firm standard. So 2 different approaches, neither one's right or wrong, but both are used in measurement. Specifically when you use norm referenced, you will often calculate a z-score so that you don't have to worry about the exact units. You just want to know roughly how well each student is comparing to the average. And so what you do is you take the difference between that student's score, or that person's score, and the average, the class average, and then you divide it by the standard deviation. Let me give you an example. I had used IQ before, and I told you that the average IQ was 100 in the US with a standard deviation of 15. So let's say that someone had a IQ of 85. We want to know, norm referenced, what is their IQ relative to the average? Well, they would have an 85 for raw score. I wonder if I can just click this in. Let's just try that, okay? And the average is 100, so notice they have minus 15. They're 15 below the average, but that's in IQ points. That's not our standardized score. So we have to divide it out by whatever the standard deviation is, and in this case it's 15. So we'd have negative 15 over 15 would give us negative 1.0. So a negative z-score means you have to be below the mean, because this number would have to be smaller than the mean. A positive z-score would be above the mean. And z-scores can be very controversial. This was a huge debate in Sri Lanka the last few years on med school tests, because we're dependent on some mean. Let me go back a slide right here. But what does that mean? Is that the average of all students taking the test this year? Is it the average of all students who have taken the test in the past 10 years? Is it comparing females to the average of females and males compared to the average of males? Or is it comparing everyone to the average of everyone? So there's lots of different controversies that can surround what norm group are we talking about? What's our norming group? Okay. A second type of quantitative data measure is questionnaire. And the only ironic thing I want to point out here is a questionnaire is often made up of statements, not questions, which is kind of interesting. A couple different types of questionnaires, Likert or Likert scales. We'll just have a statement and then you rate how strongly you agree or disagree. You've probably filled these out at the end of courses. At the end of this course, you get to tell the UNF governing body how much you liked or disliked aspects of my teaching. Semantic differential, you might not be as familiar with. Here we're picking two different adjectives that are opposite each other, and it's important they're opposite. You don't want hot on one side and boring on the other side, because it's not clear what the different measurements are in between those. But fair and unfair, we could say, oh, okay, this class is very fair, so we're going to put an X right there. Or, it's kind of so-so, so we would put it in the middle. So you have two opposites. You're marking where you feel some statement or some opinion of something goes on that scale. So some problems with questionnaires, and these are kind of funny because I'm sure you've all filled out a questionnaire without wholeheartedly putting yourself into it. So sometimes you're not quite clear what it is that you're actually measuring with a specific, you think you're measuring one thing, but it's actually something very different. This is very common. You just go through strongly like, strongly like, strongly like, strongly like, just give the same answer for everything. This one's an interesting one, even though, well, especially if it's not anonymous, but even if it's anonymous, you have this spirit that you want to be kind, and so you're giving things a little more positive than maybe your true feelings are, even though it's on a questionnaire. And then faking, this is very possible if it's not anonymous. You may pretend, on a job interview, I hear they're using questionnaires a lot recently. Do you come to work on time? Yeah, well, I'm not sure that I would answer that no, even if I don't. So some of these issues are easily controlled. Putting in positives and negatives is important. That way, if someone's just going through and checking, you can pick those people out and even remove them from the data set. Confidentiality is very important also. Observations is a third type. Could be natural, like you're standing at the back of a supermarket just watching people, or controlled. You could be in a lab counting the number of times that a student raises his hand during a classroom. Structured, specific things you're looking for versus unstructured. You're just kind of jotting down things you notice. Detached or involved. Could be observations where it's a very specific thing that you're looking for. Hand goes up. Student looks out the window. Or it could be children are happy. Yeah, that's a pretty vague thing, but there may be causes for using that in an observation. Controlling some of the issues that can happen with observation. If you train the observers, interrelated reliability, you basically allow different observers to observe the same thing, and then you see if they gave the same score, and then you maybe train them again and try again. Multiple observers certainly helps weed some of that personal bias out. Specific behaviors means that would be low inference typically instead of high inference. And not necessarily letting your observers know what you're studying. So this is not unethical versus not letting your participants know what you're studying, which is a different issue. Halo effect is funny when you have a positive first impression, so everything's positive about that person, or negative. This can happen in dating a lot. And finally, interviews. Structured means you plan out the questions exactly beforehand. Semi, you plan some questions, but you're also willing to follow the data. Unstructured, you're just winging it basically, just because you want to see what the person has to say. And some criteria that we want to look for any type of instruments: validity, reliability, we talked about that in chapter 5. You want a good description of the instrument in the study and how it was